So yesterday we talked about areas of regular polygons. We're going to continue talking about those today, but we also want to talk about areas of rhombuses, and kites. So very easy formula for you, but again, because we're dealing with so many formulas this chapter, I want you to write the formula down, then plug the numbers in, then tell me what you got when you plugged it into the calculator. So your area of a rhombus or a kite that has diagonals D1 and D2 is nothing more than half of D1 times D2. Multiply the diagonals together, take half of them, or multiply the diagonals together and divide by 2. Same thing. Okay? So diagonal times diagonal divided by 2, or half diagonal times diagonal. Okay? So first example. Okay? Formula is half D1 D2. Or D1 first diagonal times second diagonal divided by 2. Either one works, however you want to memorize it. So first example, how are we going to find the area of this kite? William? Okay, this is on your notes sheet. Okay, left side of your notes sheet. Okay, so how are we going to find the area of this kite? 5 times 11 divided by 2. So write down 1/2 D1 D2 or D1 D2 divided by 2, your choice, whichever formula you want to use. And then write down 5 times 11 divided by 2 or 1/2 of 5 times 11, your choice. What's 5 times 11? 55 divided by 2? 27.5. What's our unit? Feet squared. Okay? That's how easy those are. Next example, now I have a rhombus. The rhombus has diagonals that bisect each other because it's a parallelogram. And we see that all 4 sides are congruent. That means it's a rhombus. So what will my equation say? Yep, 24 times 10 divided by 2. What's 24 times 10? 240 divided by 2. What's my unit? Millimeters squared, because we found the area. Okay? No major issues on those, right? Okay? Wouldn't that be nice if everything was like that? Okay? Next example. Okay? Next example has a regular polygon. And now we want to find that area of that regular polygon. So I want to point out something on your notes. In that box on the right-hand side of your notes, I have a polygon with an apothem and a center and a radius all denoted for you. But very, very important, down below talks about the central angles. And it says that 360 divided by n not only gives us our exterior angles, but it also gives us the measure of the central angle. Okay? So you want to highlight that or put a star by it or put a box around it or somehow make a note that that's important because it will help you. Okay? So our next example says, find the measure of the angles in the regular octagon below. So, decagon, thank you. Decagon has how many sides? 10 sides, n equals 10. The first angle they're asking us for is angle KPJ. K to P to J is the central angle right here. So, what can we do to find the measure of the central angle? Take our 360 divided by n, right? 360 divided by 10 is how much? 336. That's this big angle right here. Okay, each of these central angles is 36 degrees. Okay. LPK will be 18. Why is LPK 18? Half. We've dropped an apothem in there. It bisects the angle. So 36 divided by 2 is 18. And then how do we find angle JLP, the base angle of that right triangle? The triangle is 90, is a right angle, right triangle, right? So 90 from 180 is 90 left for those two. So how do we find that angle? 18 minus 90 is 90 minus 18 is not 62 but 72. So this angle is going to be 72 degrees. Because we have a right triangle here, and we have, so 90 degrees is already taken up, and 90 minus that 18 degrees, that half that central angle, is going to get us our others. Okay? So far, so good? Which part? We're good? Okay. All right, next example. We have a regular hexagon inscribed within a circle, and it has a diameter of 32 units. Yesterday we didn't work with the diameter, we worked with the radius. So what's the radius of this circle? 16, half the diameter. So if the radius is 16, we need to find the area of the hexagon. How many sides in a hexagon? 6 sides. What will its central angle be? So we have a 60-degree central angle. That means that if I drop the apothem in there, what's left? 30 and 30, right? In order to find the area of a triangle in a regular hexagon, we have to find the apothem and the base. So we need to find A and this little base. Now we're in a different spot, right? Yesterday we had our angle, our base angle down here, but we're talking about half of this central angle. So if I want to find the apothem, how is the apothem related to 30 degrees? Next to it, right? Adjacent, so that means cosine. Okay? So cosine 30 is equal to the adjacent over the hypotenuse. To solve that, we simply take 16 times the cosine of 30. So 16 times the cosine of 30 gets us what? $13.86. All right, so we found 13.86 as our apothem. Okay. Now we have to figure out 16 times the cosine of 30 gets us 13.86. Okay. And now we need to find our little base. Okay. How do we find our little base? Well, how is it related to the 30? Opposite, so we'll use sine, right? Sine of 30 is the opposite over the hypotenuse. So 16 times the sine of 30 is going to get us our little base, which is sine of 30 is half. Half times 16 is 8. That's our half base. What's our whole base? 16. Okay? So to find the area of one triangle, we're going to take the apothem times the base divided by 2. How many triangles do we have altogether? 6 sides, 6 triangles, right? So our area will be 6 times the apothem times the base divided by 2. So we get what? Very good. And we don't have a unit here, so we'll just say units squared. Okay. What questions do you have on this slide? Okay. We're good on this one? One more to go. Only one more. This one is a mirror, and it is the shape of a regular nonagon. How many sides in a nonagon? 9. Okay. So each side is 6 inches, so we already know our base. The only thing that we don't know is our apothem. Okay. So how many degrees in a central angle? Good. 360 divided by 6 is going to, or by 9 is going to be 40 degrees. Okay. So our central angle is 40. That means that when we drop our apothem in here, we split that central angle, and what do we have left? 20. Okay, that's our central angle. All right, so we're dealing with that 20-degree angle. We're trying to find A. How is A related to the 20-degree angle? Careful. Careful. We're going to use the tangent because the 20 is next to touching that 20-degree angle, the A is, not the hypotenuse though. So A is the adjacent. And we have the opposite. So if the whole base, absolutely. So if the whole base is 6, what's half the base? 3. So our little mini base is 3. That's our opposite. Our adjacent is A. That's what we're trying to find. So since we have opposite and adjacent, that's the TOA part of our SOHCAHTOA. So we have to use tangent. What's wrong? Okay. Okay. So we know we have opposite and we are looking for adjacent. That means we're using the tangent of 20. Tangent of the angle equals the opposite divided by the adjacent. So we want to get the A by itself, right? It's currently being divided. What's the opposite of division? Have to multiply. Yep. If we cross multiply here, A times the tangent of 20 is equal to 3. So we're trying to get the A by itself now, and it's being multiplied by the tangent of 20. We got to divide, right? So A is 3 divided by the tangent of 20. I got 8.24. 3 divided by tangent 20 equals. So when you have to hit the equal sign. Yep. So you have to hit the equal sign because when you just hit the enter, it's going to, or when you say tangent 20, it might just tell you what the tangent of 20 is. So when you hit equals, it will be 8.24. That's my height. Okay. If that's my height, now I need to find the area of the whole polygon. We just took 3 divided by the tangent of 20, and that's right here. Oh, that's this guy, 8.24. That's A. Yep, that's the apothem. Okay. So then we need to find the area of the whole nonagon. How many triangles will we have? 9. So we take 9 times the apothem times the base. What's the whole base? And then we're going to take that time divided by 2. So 9 times 8.24 times 6 divided by 2, 222.48. And my unit is inches squared. Okay? So you don't have to use that 9-step process. You can simplify it now that you've been through it before. Oh, it's about the same. Okay? There's a lot to it. You still have to. You just don't have to formally do it. If you prefer to have that pattern and that step-by-step process, I can print that out on a little sheet and you can use that. Okay? Okay. You bet. All right. So assignment, back side of this sheet. These are your notes. Flip it over. You've got your assignment. Okay? Give me 1 second.